Yeah, hey everyone, welcome back to my YouTube channel. Today we are gonna explore loops and around agents. I have been building a voice agent for a e-commerce AI native app, and it's been fascinating how things are moving quickly and how it feels when you build one such agent. From high level, you will think that it's nothing special, but when you get involved with uncertainty of LLMs, then you will get to know how hard it is to build a deterministic system. All right, so without wasting any time, this is the architecture, like a high level architecture on what goes behind making an agent. I have not gone deep down into models and all and embeddings and all of those things, because those things will come into play once you have some data. So let's get started. Every time you build a system, it is to solve a problem, and by solving a problem we mean, so there is an input, there is something which user wants, and at the end the user should get it, or that should be the output. All right, so with that in mind, there is a, like in the voice agent there are few layers on top. I will just cover these on top. Like I won't go drill down into STD, DTS and what all these things are. We will focus more on the agent model plus harness part. All right, so while building a voice agent, there are few steps involved, which is different from a text agent. So obviously the latency will be higher than the native text agents, but also right now there are some voice to voice agents, voice to voice models that are real time model. Gemini and ChatGPT real time models are coming up. All right, so in a voice agent the input is always a voice. There needs to be some sort of voice hardware, some mic or something. So let's say we are building a voice agent for a mobile device. The input will be the voice coming from the mobile device mic. As soon as you get the input, you feed it to the STT model, which is speech to text model. There are a lot of tools out there. Such like few I have listed: Deep Grammar Assembly and OpenAI Whisper, which takes a audio input and gives you text. And once you get the text, that is fed in the agent, which is LLM model and the harness around it. And then the expected output is like you will get text, you will convert it into audio, and then at the end you will send that audio to user speaker and they will listen to it. So this complete flow is the high level flow of what a voice agent does. And the interesting and the most difficult part is this agent, that is model plus harness. It's not a one shot prompt engineering, or it's not a one shot input. There needs to be set of complete feedback loops which needs to be covered around input, output, context, system prompt, text input, all of those things. So I have broken down this below. So let's take a look at this. The system will start from the input. The user has some input, so this will cover apart from this to this, and all of the other things are just basic native APIs calling, nothing else. The user will have an input. There will be always a system prompt which will instruct the model that hey, behave like something, and this is the guardrails that you have. This is how you should act. This is the type of things you should not do. This is the type of things that you are made to do. So all these things are covered in your system prompt. Then this is user input. Then there are some session messages, which basically is continuation of the current session. Like it's not you give an input, you get an output, that's it. It's like you get output, you then define it, then user asks for something else, then they ask for something else, and the things continues. And along these lines there is some memory layer which is built out of it, like which is depending on user input, how user behaves, how user thinks about the output, if user is satisfied or not satisfied. All of these things contributes to the memory, but all of these things contribute to the model context. Like each and every AI model needs some system prompt, along with like they needs the context around it. So if you can make more richer the context, the output will be more richer, which is basically more personalized. So let's say the context is built, then you send it to a AI model, which is like there are a lot of models out there. So once you have this, then takes the system prompt, takes the user prompt, then predicts something, and then they gives an output. Let's consider that output is a JSON output. Once you get the JSON output, you will ask model that hey, my work was done, or what's the next set of things to do, or whatever you have done, just list it down. And in this process there will be multiple tool calls, MCP calls, or call them basically some tool calls, or let's have some MCP, normal APIs, normal database fetching. Let's have normal DB fetch, move this, and they can be normal API calls, which can even be in MCP, or let's say these are for external sources, these are for your internal sources. So all these things are the way which model uses the data which it do not have. All right, so you can just consider them as a tool that you give an LLM full control of. Like hey, go ahead, you are allowed to do all of these things, just make sure you call the right set of tools at the right set of time. So all these things will be there in system prompt, and all of the prompts around these documentations and all. Then there are concept of skills and all, I won't go there. So once model decides something to use or do something, let's say they do a DB fetch, they will give a JSON output that hey, this tool needs to be called. Once that tool is called from your system, like this let's say this is gonna call the DB fetch. So this is the caller, like your system will always be the caller. Once you get the like once you make the call, you will get some output. All right, let's say this is the output. Once you get the output, that's encapsulated in a complete output, and there's also that will also symbolize that, hey, is the work completed or not. Once you have this, if the work is done, you will send off the final output to the user. If it is not done, this will again contribute to the context, like all the input combined from the tool calls or from the LLM thinking, everything will go in context. Again, it will go into models. Same thing continues, and once the model thinks that, hey, the work is done, it will just add the key in the JSON output and will raise the final output. So one thing to make sure that the loop should not exceed some maximum iterations, because if you are making it to just be turned on and on and on, model can hallucinate and it can select same tools which may fail or may not fail and can give you same output. So there should always be a max iteration set. This is basically breaking the loop. If there is no break in the loop, then the agent will like just burn your complete purse. So all these things, like there can be max iteration, there can be some deterministic conditions, maybe some rejects or something. There might be some non-recoverable errors which you cannot retry. So I won't go into retry thing right now. And then there can be like model things work is done, that is we have covered, and then there can be a user input layer. Like let's say there is a shopping agent and user have asked you for some products, you showed user some products, user asked you to buy it for it. The model do not have PII, like the user card, user address, and all of those things. It will hand off the control to user. It will ask user to make the payment. Once the payment is done, it will again go into the loop. Like there will be an input context. Model will see like, hey, order was completed. It will just synthesize the output and tells you, hey, my flow is done. Just go ahead, and the final output will be released. In this complete process, there will be a lot of inputs, a lot of tokens being going here and there from model to output to again context to again model. All of these things will contribute to your memory layer. There might be some tool calls that will, let's say, update your memory. Like let's just make it out. There might be some tool calls, like let's say add memory or something similar. Once this tool call is called, like once model thinks like, hey, this is an interesting fact about user, let's add this, or user have asked it to like, hey, save that I like maxi dresses in my preference, it will call the add memory tool. Add memory tool will update the short term memory as well as the summarize tool output, the summarize tool memory. So there are a lot of types of memory depending on what's the use case. They can be long term, short term, the current context summarizations. Like as I told before, you are passing the session messages, but let's say the session have exceed around 50 conversations. If you just pass everything, the context will just bloat. So you do not need that. You need to have some maximum cap limit and then summarize the rest. So all these things model can decide, or even you can decide, like have some hard-coded rules. Like let's say if there is more than 10 iterations, you are gonna summarize the other messages that were there in the past. All of these things contribute to the memory, and they again go into the context. So this is how a self-learning agent or a personalized agent will behave. Now there can be like long-term memory cannot be built in the current session. Like it can be, but it won't be that much used, because let's say user is buying for someone else and they say like, hey, I'm buying for my sister, she likes maxi dress, but that does not mean that the user like maxi dress. So you cannot just save that fact to the long-term memory, because that's not related to the user. The work, like the long-term memory is always like, it's up to you how you do it, but it's mostly updated by some background process which can run every day. Like it depends on how you want the memory to be. For some system you want the memory to be updated right ahead. For some system you can like take a day or two to update user memory, which you call it like long-term facts. And then whenever next session user comes up, you can just use this memory. This will again go in context and the system will be more and more personalized. So how the long-term memory can be updated, you can use any small model or anything. Like there can be a layer of regex, but it's not very simple. Like it can be having some non-deterministic effects. So generally we use a small model which does not cost much tokens. You just feed in the complete, like once you get the output, all the text messages, all the output will be saved in a DB, and this will be become a source for your cron process. You process the messages like, hey, these all the messages user have sent. We have sent this as an assistant message. User react like this. Once you know all of these, a model will just loop around the messages, see, hey, is there any effect that I can store in? Once it find it, it will just save it to long-term memory. So that's how this agentic systems and all of these things work. I haven't gone into depth of it. Maybe next video I can just create on a depth of like e-commerce voice agent or maybe something similar, or a customer support voice agent or a phone call agent or something similar. So I hope you have learned something, and if you have any doubt, just add in the comment section. It's not as much complicated, but when you try to implement it and you see model hallucinating, there are a lot of things that goes beyond this harness. Like that's also part of harness. All the evals, all the like evals can be of any type, all the test cases and satisfactory scores, all of those things become a part of this harness, which maybe we'll cover in next session. So I hope you find something useful. So that's it.